Hi, I would like today discuss the vadis oncological hyperthermia in 2020 and how the trends are from this time. So I have collected some questions which are looking for answers. Challenge of frustration, challenge of complexity, challenge of fight against cancer, technical challenge, immuno-oncological challenge. So we have challenges a lot, and this is why I would like to discuss the points. The history of oncological hyperthermia has a lot of frustration and skepticism. The masters in ancient medicine are Hippocrates, Rufus, and Szasz, who had used hyperthermia for a long time. The follower much later in 18th century, Joseph Récamier, who had continued the work of the ancient physicians, and very soon it was divided into dominating models or groups. One is for electric effects and the other one for thermal effects. And two very giant physicians were working in this one, Arsène d'Arsonval, French, and Christian Overgaard, Swedish physicians, who are continued the separation of the two dominant groups. Very interesting that they started to develop independently, and Arsonvalization and radiofrequency medicine was in one part, and radiofrequency and microwave heating and infrared heating in the other part. So the separation was really complete, and the electric effect were not fully accepted in oncology, and it mainly was used in non-oncological points. Temperature became the basic of the standardization of hyperthermia. But interestingly, nowadays we have a new trend that in the electric domain we have a resonance effects more and more interesting, and in the thermal effects we have molecular studies which are also the trend. And the most important one, that these both are going to the same route back, the immunogenic effect. So it means again they will united, and the two approaches will be the same. I will show it later. Now it's really interesting to see that there was a blaming game. In 1967, 64, was the explanation by a German, famous German oncologist, that the hyperthermia impresses the patients very much, but do not impress their cancer, so it means it's useless. Then, more than 10 years later, it was declared that microwave hyperthermia device is a gun shooting in the dark room. Again, more than 10 years, and it was telling that mistakes made by hyperthermia community has to be not repeated. And again, almost 10 years, and it was somehow discussed that the physics is against us to reach the normal temperature. And then later, it was telling that the physiology is against us to reach the normal temperature. And in the last year was a real turn in the full blaming game when the Charité professors in Berlin had shown that physics is our friend. So we have to recognize it. So the local regional hyperthermia has very different methods, but the two main domains of the methods are the isothermal local heating and the non-isothermal local heating. It means that this has artificial focusing from outside and trying to make an absolutely homogeneous temperature in the tumor mass. Radiative and capacitive approaches are used for that one, that really heat as homogeneous as possible the tumor mass. The other one is a non-isothermal heating, when we heat up the macro rods or micro rods or nanoparticles inside, which are injected into the tumor, and it means that one that we not heat the full tumor, we heat only the particles which are in, and these particles heat up later the full tumor. Here is another non-isothermal heating, that is when no extra particle are given in. The heating is in the cell membrane of the malignant cells, selective heating. So it means it's the same like the additive particles, only without additive particles it's used. This is a modulated electrohyperthermia. The challenge of complexity is the other problem of oncological hyperthermia, that really the thinking is somehow very rigid. This is an inductive thinking first, which is studying the details and build up the system from this one. And ancient oncology used hyperthermia for this and tried to recognize where is the organ or tissue failure. And this old approach was reduced to that failure. So this is a reductionism which dominates the present medical practice. Deductive thinking is the opposite. In ancient oncology, it was a herbal medicine which used it. They studied the system, and from the system was studied the details, and it was looking for energetical failure in the system. And this is a holistic approach which dominates the traditional Eastern medicine nowadays. A great step was done by Bruce West, the chief scientific officer from Army Research in the United States, publishing a book that where the medicine went wrong, and realized that we lost the complexity. We have to go back and use both approaches, the inductive and deductive. In malignancy, it means that the malignancy is a complex phenomenon, so we have to use both the approaches for the malignancy as well. So in oncology, the task to destroy the tumor effectively and measure it in local control, this is an inductive reductional thinking. And here is the other one, when you are dealing with the full system, block the invasion and dissemination, eliminate the metastasis, and measure the survival time and quality of life. In hyperthermia, destroy the cancer cells is inductive, and block the systemic effects is deductive way. Complex thinking is necessary in hyperthermia. What it means really? The living complexity is a very complicated point. You see that it has different approaches, different factors, homeostatic regulation, personal conditions, environmental loads. And to this all complexity, we have to choose the applied treatment for the tumor. So the physician is always in the dilemma what to apply, protocol A, protocol B, or what is the best possibility for the patient. Many times it is a dead-end fight because the whole patient is not known well, and maybe that we are not treating optimal the patient in the given point. The result of complexity makes it even harder because it is not such decision that true or false, black and white, yes or no, but degree of truth has to be seen. So it's a gray zone, and this makes the decision even harder. Hyperthermia complexity is a very special point of all. So we have energy absorption, and energy absorption divided in two parts: energy dissipation, which makes heat, and chemical excitation, which makes changes of different point. The heat makes a condition for action. So the condition, energy dissipation, action, chemical. Heat production is the condition. It depends on the square of the electric field, and it has a physiological condition things which favors drug permeability, oxygen sensitizes radio, more chemo drugs delivered, pharmacokinetic increases. But it has contrast. Glucose delivery increases, metabolic activity increases, and dissemination increases if we are not taking enough care. In cellular points, the conditions are favoring. The intercellular pressure increases, so can destroy the cell, membrane damaged, cellular selection can be done by HSPs, and could cause necrosis, the heat. The contra are the stress resistance increases, so it means HSP could be not only positive but could be negative. The special anaerobic metabolism is in action and more supported, and immune decreases more than 42 centigrade. So the contrast requests attention for not a high temperature. So it means the mild hyperthermia is preferred by the conduction part. In action part, which is proportional with the field itself, so not the square, but the field, its chemical selects the membrane rafts, excites the intercellular signals, makes apoptosis and intercellular reconnects the cells, and the contrast jump the E field could make a burn because of the adipose tissues mainly, and personal sensitivity modifies. But it has a very great advantage, immunological, which is favor cell death is immunogenic, presents tumor antigens, tumor-specific immunity can be built up, systemic abscopal effect can be produced, in situ tumor vaccination can be established. The contrast, patients' weak immune system could be a contrast of the immunological actions, and long adaptive time of the immunology is a problem. So contrast requires adequate technology and protocol in this molecular changes. The other one is the change of the fight against the cancer. This challenge is really a very sophisticated one. So the first, change the strategy. We are in the war, attack the weakest point of the enemy. This is the strategical point. And it's unfortunately the strongest point, the proliferation of the cancer. This is always targeted, which is not a good strategy. The good strategy to attack the weakest side of the tumor, which is the missing networking. So it means the individualism of the tumor cells has to be used for that one, that really eliminate them from the body. So these are the points which we think that necessary for the trend in the next years in the strategy. Instead of dogmas, follow the trend. So instead of destroying only the tumor, follow the trend that homeostatic immunoregulation is necessary. Instead of isothermal heating of the tumor mass, we need a selected heating of the tumor cells. Instead of the large energy to heat the anti-tumor, we need an optimized energy to heat the cancer cells. This is also a safety issue. instead of the tumor size reduction, we need a survival time and quality of life increasing. So the consequences are very serious. High homogeneous temperature was requested till now by the dogmas, but we think that the trend will be the immune recognition control. Not only the strategy has to be changed, but change the paradigm as well. In 2 points. The first is from tumor-oriented, we have to go to the patient-oriented approach. So the tumor manifested in the localization, but you know it's only looks like that it's there because the tumor is not there. The tumor is in the patient almost everywhere because they're circulating tumor cells. So we need them to mention that do not treat the tumor alone, treat the patient with tumor, which is the main task. The next change of paradigm is from product-oriented to process-oriented point. For example, this one is the water filling up a glass and its overflows, and it's impossible to block it by a finger here. So it means you have to apply something else, and this finger block is the same like the chemotherapies, having the products like evolutionary products, replication, angiogenesis, signal pathways, so like HSP70, HSP90, different blockers, and so on. It looks like that we would like to block the system in a point which is impossible. So we have to block here at the dynamics, at the process. So from product-oriented to process-oriented has to be the line of the treatment. Evolution processes, immune effects, feedback gaining, complexity has to be taken in consideration. So it means the tumor is here and metastasis is formed, then local treatment has to be applied, which local treatment must be curative when we are taking effect on the dynamics, so the therapy concentrates on the human complexity. We know it very well that every dynamic changes have two sides, promoters and suppressors, and even it's in social life we have such things. But in life, in the chemistry, the initial products and final products have also this balancing by the promoters and suppressors. So it means the promoters, suppressors will balancing each other to produce the best final compound. And these balances are interconnected. Many of them are interconnected. Presently, I had shown only 4, but of course much more in the body. And this like a balance that you have promoter and suppressor, and the negative feedback makes the regulation in balance, the torque wave in balance. But if you have some problems, let's say a suppressor will be weaker a little bit, then you add a little more suppressing something and try to establish the balancing, which is okay. But if one part of this both is not well evaluated, then the torque is larger and it's an unbalanced situation, and unbalancing will change not only this type of balance, but will change very other balances which are interconnected with this one. So the curative strategies could be that one which I had shown. For example, the promoter is weakened, so it's a disease, and then we add something, having again the balancing. But when the promoter in this balance is okay, but the promoter involved in many other balances, so it means that you have started to make a lot of side effects. The other facility, when again the weak promoters, then you are changing the reference points. It means that the turning points of the balance, and rebalancing on such way. It's also a rebalancing. So like let's say you are giving a pyrogen to increase the temperature of the body, and then changing the reference point in the hypothalamus instead of the body temperature 37, let's say 38. But this again will change all the others, other balances, so you cannot calculate what is happening, and it could be really uncontrolled treatment in all. The real point which we have to do, that is go back with the promoters in the normal way from the weak one to the normal one, and for this one not use only this type of balance, but use all the balances around, so take care about the complexity in full. In this point, you can rebalance everything in the normal way, and you can rebalance this one as well, so the patient is cured in full, in total, in the place. The next is a technical challenge, which we have really very seriously. Technical challenge starts with the dose problems. The dose presently is a cumulative equivalent minutes in 43 centigrade in T temperature at X portion of the tumor, and we can see from the in vitro experiments that measuring the necrosis at 43 centigrade, that it could be fitted to the R below and over 43 centigrade, and the SAM is calculated on such way like this one. It's very complicated, and the problem is that it's not true, because the Arrhenius plot which was fitted by these things, changing, varying by cells, tissues and species. For example, in mouse, in living, at 43 centigrade it's 0.25, which is okay, but in human it's a little bit higher temperature, the Arrhenius plot, and 0.13 and 0.72 instead of 25 and 0.5 here. When we have HSPs in the cells, then even higher temperature necessary for that one, that really having the break in Arrhenius plot. And then instead of 0.5, we have 0.3 only. In the burn, in the surface burn, we have 0.4, which is nearer to this one, but not 0.5. And in vascular disruption, which is 44.5, we need 1.1. So it's really absolutely different ask, which questions the CEM. So if we have a temperature development, then the temperature development is very easy at first, going up, then saturates, and if we switch off the power, then it goes down. But at the beginning, it has a linearity, and the slope, which is delta T per delta T per time, so how the temperature changes by time. This is the real SR, the specific absorption rate in watt per cubometer, which is the provided power from outside. Later, it starts saturation, and SR only compensates the energy loss by perfusion only. So the temperature which is reached here is about the SAR divided by the blood perfusion, and then it's kept constant. So it means that nothing else changed, only the blood perfusion is compensated. And then at the end, we have a washout process, which when we switch off the power. But you see that it's a very different request than the CEM. It's really somehow connected with the SAR, because the SAR is in the active period of the absorption by the tissue. So in the clinical data, they observed in 420 patients by Frankena and others, published more than 10 years ago, that the T-rise will be the good dose, and T-rise is such one that they are calculating the delta T per delta T, so the same like this one. It's very similar to SAR, but so it's corresponding principle. But this T50 is again the isothermal dogma, that you are isothermally heating everything and trying to have at least 50% of the tumor on the T temperature, and this difference through the duration of the full treatment gives the SIR, which is of course a very huge averaging, and the correct clinical dose cannot be such unprecise thing. So precisely you have to measure the SIR, SER, and then from this one makes the by integration the absorbed energy, which is joule per kilo. So the same gray can be used like ionizing radiation. The technical requirement is very serious, because for this one that you can use this, you must have a high efficacy of the energy absorption. So it cannot be that one that somewhere we have a loss of energy in the space. So when the energy absorption is not concentrated on the cancer, so it means we have a lot of lost energy, then the temperature measurement is mandatory, because from the temperature we can approximate how many the SIR which is absorbed by the tumor. So the heating paradigm very well shows this problem, that you see that there is a facility that independent, the source and the tumor are independent, and independent source, homogeneous isothermal heating and preliminary planning decides of this all. But the other facility, when we are switching on the patient in the circuit, and the patient has a feedback from the electric status. Of course, it's non-homogeneous, non-equal selective things, and then adaptive for the patient in the actual status. So the losses are very large. So if we have an energy source, and then we calculate how many losses we have all over, then you can see that we would like to heat up only this part, but a lot of losses are around. So we have to have such a facility which must have a high precisity, and this is the patient who has the resistivity which is necessary to absorb, but we have a lot of adipose tissue and others, which is a condenser. If we add an inductivity here, then we can have a serial resonance which makes compensate the condenser, and then it will be virtually zero. It's an ideal solution, and remains only the resistance which is necessary. So if the tuning is well done, then remains only the resistance of the absorbed energy. This is the trend. And then at the end, the trend of immuno-oncology challenge. We know in immuno-oncology that CAR-T is the present star treatment, having 6 steps and taking away a sample from the patient, and then actually making a labo treatment of this part, developing immune reactions, and give back to the patient. Of course, we can do it without this laboratory part. For example, we have observed in radiotherapy that it does abscopal effect. So it means that radiotherapy, if given, then far away on distant metastases we can act. So it means immune action can be developed. But the problem is that it's only valid when the dose is very small, but which we are expecting the DNA breaks, and the dose needed high, because of the break is the goal. So it means the abscopal effect cannot be used in the radiotherapy. But in hyperthermia, you can do it, because immune effects can be produced inside if this will be the trend, and without that one, that really destroying the hyperthermia itself, because the selectivity for cells could be valid. So it means that that it needs a special hyperthermic method. So for example, if we have here a tumor in the colon, then of course this tumor enlarged, this one is the inside the colon, the tumor which has to be selected. Then here's the tumor, and inside the tumor we have to select the tumor cells, which we can do, and then the tumor cells are absorbing the energy, excite the DES receptors, DR5, which we have shown that we can do, and the future is that one that we will do. This induces immunogenic cell death. Immunogenic cell death induces calreticulin, ATP, HMGB1, and HSP70 outside the cell, so in the extracellular matrix, and this gives a maturation of the dendritic cells, forming antigen-presenting cells here, and antigen-presenting cells will train the T cells what is the genetic information from the tumor, and then the training is that one that we have a tumor-specific adaptive immune action in the whole body using the CD4 helper T cells, killer T cells, and gamma delta T cells, and all are attacking the tumor very directly. So these were the answers for the present present knowledge, and I am really very thankful for your attention. I hope that this conference will be a success.